And in this loading scenario, because there's no other forces acting on horizontal forces acting on member AB, that means there's no other forces to balance this shear force. If you have a shear force, that means the moment must be changing. But at point A, the moment is 0. So that means it should not be changing here. That's why here, this shear force should be 0. Because this VA is how this internal moment is going to balance with. It's going to balance this internal moment with the VA here, not the VA here. So there's no VA here. This one. That's why we don't consider it here. And if we say that, recall the definition, an internal moment is negative EI times y double prime. Then the Garvin equation becomes negative EI y double prime minus P plus MB over LB times Y plus MB to be 0. Or you can write it as EI. Of course, this EI must be EIC because this is EI column. EIC times Y double prime minus plus P plus P plus MB over LB times Y equals MB. MB was converted into negative sign, but if you move from the left-hand side to the right-hand side, it becomes positive.
Professor, why it's LB?
Yeah. What's that?
On the textbook, I saw it to be MB over LC.
It's MB over LC.
Yeah, I kind of confused anyone.
Okay, I think that is because here, we don't consider this VA here, but the other VA here is MB over LC, right? So also we don't consider this VA here, but we have to consider this VA here, which is this one here. And by taking the moment at here, that means we have to include that part in our moment equilibrium. So we actually need to correct this part by writing, actually, we need to correct this part by expanding this one here. So the moment equilibrium should be like this. We have this part, and then this moment produced by the force VA, with respect to this red cross point, is positive or negative. It will produce counterclockwise moment, so it's going to be negative. Right? With respect to this point here. With respect to this point here, this VA will produce counterclockwise moment, so it's negative. That means it will be minus it's VA, but we're just going to use MB divided by LC. And the distance is from this point to this point, and this distance is X.
We're summing moments but around the point B though, so the distance would be 0. Right? Because we're summing the moments at point B.
No, we are taking the moment at this red cross point. taking moment here. That's what we are doing. So the moment produced by VA will be negative, and that is going to be MB over LC times X. And then the last term is positive. That's MB plus MB to be 0. Now, in the textbook, they made an approximation. They assume that this value MB over LB, this one here, they assume this is very small. And in most cases, it is possible. So the theoretical expression for this one, by considering all terms, is written this way. So if you divide everything by EIC, that will become y double prime plus P over EIC plus MB EIC over LB. Of course, this has to be this whole thing times y. And plus MB over EIC over LC times X. And this, do we have everything? This will become negative MB over EIC to be 0. So this is the theoretical expression for everything. But from the textbook and also from experience, we know that the shear force produced by the moment from the beams acting on the column members is usually very small. So the value of this term here, is usually neglected. You can see that on the textbook that Professor Chen and Professor Louis, they just ignore this part. They said this part is approximated to 0, so we're not going to consider it. We only consider this one. That's why they don't have this term in the analysis. That's one. And secondly, when you look at this expression here, you notice that by canceling out this term, the moment produced by MB times y here, which is, this is X, and y is from this point to this point. This is a y, right? That's how you produce the moment with P plus MB times LB, which is this part. And we will also, by considering that this part of the moment is not that significant, we'll also cancel out this part as well. Because the moment produced, if you look at the terms, the moment produced by this MB on the column is the shear force coming from the beam member BC. So by canceling out this term, the same reason we're going to use to cancel out the moments, this value, which is MB divided by EIC. In theory, we need to consider both terms. But practically, we will just cancel these two out because if there are two, one term is very small, the other term is also very small. So that's the reason why if you look at equation 4.2.1, this is on page 239. White found their force equilibrium, they only have 3 terms, and here we have 5 terms because they assume that this moment is very small. So usually we ignore the shear acting on the column, which is a member AB. If you can ignore the first term, then you can ignore the second term. So by doing so, the Garvey equation is written as y double prime plus, here we're going to call it kc square times y.
Professor, I can see what you're writing.
Okay. Can you see it now?
Yes.
Okay. So we're going to write this be MB LC times X. So this is for member AB.
Professor, can you just go back for 1 second?
Yeah. Actually, I missed the EI. Now I just noticed this. Everything will be divided by EI. So this should be EI C over LC. And KC square is P over EIC. That means it's only the properties for the column. Here, member BC is the column. I will just use member here. Now, step 3. You already know that with this kind of problems, it's a second order differential equation. And the complementary solution for the column member, we're going to call the solution YC of X. We have, first of all, is the general solution, the particular solution. The first one is A times sine KC times X plus, of course, is sine of KC times X plus B times cosine KC times X. Of course, I already skipped 2 sets of parentheses here because that's what we have been doing from the very beginning. Plus the particular solution, which is the original solution divided by K squared. And that will give you MB over just P times LC, the whole thing times X.